Good day and welcome back to our sessions, and today we are going to be focusing on revision of May-June 2024 question paper that was written on Friday the 3rd of June. So we just want to be able to review this question paper and to see what were the possible solutions, how did they examine you, and at the same time what solutions we are supposed to provide for this question paper. So without wasting time, we shall start from the first question. But those who want to access the question paper, they can access it on DBE portal and also SA Papers portal and other portals that provide past papers. So let's move on. And also those who have access to Facebook, you can as well access this question paper on my Facebook page, which you are going to see there in the comment section of this video. So let's start at this point with the first question, or the first group of questions, which is the algebra topic. So on the first topic, we had the first question, which was a binomial, that was 3x squared plus 5x equals to 0. So on this question, what you expected to answer this question is that you needed to know that it's a binomial, which is in terms of x. So what you need is only to find the highest common factor of this, which is x. In this case, you have 3x plus 5 equals to 0. So after that, we need to be able to solve this. That means x is equal to 0, and the other bracket, 3x is equals to negative 5. So from this point, divide both sides by 3, which means x is simply equals to negative 5 over 3. So this is for 2 marks. You get to 2 marks here out of solving in this way using highest common factor. So the next question was also the quadratic, which is question 1.1.2. So the question was 4x squared plus 3x minus 5 equals to 0. So this question, the only way to solve this question is by using a quadratic formula, because the question has an instruction that you should solve this correct to 2 decimal place. So using quadratic equation formula, x is equal to negative b plus or minus b squared minus 4ac divided by 2a. So let us substitute. The next step is to substitute. So x is equal to negative 3 plus or minus 3 squared minus 4ac, which is negative 5 divided by 2a, that is 2 times 4. So from here, you need to punch a calculator in order for you to find the values of x. After punching calculator, we'll find that the first solution to this is that x is equal to negative 1,55, or x is equal to 0,80. So these are the two solutions correct to 2 decimal places, which means you need to leave 2 numbers after the comma. So we move on to the next question. The next question is also about a quadratic inequality. So how do we solve quadratic inequality? Our quadratic inequality was x minus 1 squared subtract 9 is bigger than or equals to 0. So this was the quadratic inequality. So the quadratic inequality, you're supposed to expand this bracket using FOIL method. X minus 1 subtract 9 bigger than or equals to 0. So expanding this one, this will give us x squared minus 2x plus 1 minus 9 bigger than or equals to 0. Let's make it a proper quadratic equation. This is going to be x squared minus 2x minus 8 bigger than or equals to 0. Now, in order for us to find what are called CVs, or critical values, we need to be able to find factors of this quadratic left-hand side using either factorization by inspection or using quadratic formula. But using quadratic formula here is going to waste time or take more time, because exam is about time and accuracy. So let us use factorization by inspection. How do we do that? we need to find factors of negative 8, which are negative 4 times 2, or negative 2 times 4. But amongst these factors, which factor is going to give us negative 2 when we simplify it? It is the first pair. We are going to have x minus 4 and x plus 2 bigger than or equals to 0. So that means that the critical values that we are going to have here, the critical values are such that x is equal to positive 4 or x is equal to negative 2. These are the critical values. But for us to be able to know which inequality are we going to use, we need to be able to make a proper assessment by using a rough sketch of a quadratic graph. We are going to have negative 2, we are going to have positive 4. Now, we come to this, we look at this. This is greater than or equals to 0. A greater than, it means that our solutions are found above the x-axis. A greater than, it means solutions are found above x-axis. What do we have above x-axis? We have our graph going to the right from 4, going to the left from negative 2. So therefore, going to the right, it means values are becoming large. X is bigger than or equals to 4. Or x is less than or equals to negative 2. This is how we find solutions. So if this was less than, we are going to focus below x-axis and we put our x in the middle, and it's going to have parameters of minus 2 until positive 4. This is how we solve a quadratic inequality. So we move on to the next question. Our next question is going to be about exponents. Our quadratic is in an exponential format. So how do we solve quadratics that are in an exponential format? We are going to have 5 exponent 2x minus 5 exponent x is equals to 0. This is the question out of 4 marks. What we're supposed to do first is to make sure that we use a K method so that we turn it into a proper quadratic equation. And this is going to be, let K be equal to 5 exponent x. After this, it means that K is going to be squared because 2 squared remains here. Subtract K is equal to 0. Let us solve this. Solving this one means K outside K minus 1 is equal to 0. So we have 2 situations here. That means K is either equal to 0 or K is equal to positive 1. Let's bring back 5 exponent x. So 5 exponent x is equal to 0 or 5 exponent x is equal to 1. But we know very well that as long as we have 0 here, we cannot have a logarithm of 0. So that means that in this case, 5 exponent x is not equal to 0. So therefore, it's not applicable on this side. On the other side, this one represents 5 exponent 0. That means x is equal to 0 final. So you have 2 sides of this, which means 5 exponent x is not applicable. 5 exponent x is going to give you error because of 0, and 5 exponent x is equal to 5 exponent of 0. Therefore, x, as long as the bases are the same, it means exponents will be the same. So let's move on to the next question. So the next question, we have a quadratic expression which is x divided by square root of 20 minus x is equal to 1. So the first step in this case is to transpose this denominator on the other side so that we break the fraction. So this means x is equal to square root of 20 minus x multiplied by 1. But we know all the time anything multiplied by 1, it remains as it is. So after this step, the idea of this is to make sure that, let's make sure that our square root is on one side, it's isolated. At the end of the day, we can now introduce square root on both sides. Introducing a square. Because of a square root, let's introduce a square so that we can cancel out this square root. We square both sides, we square both sides. This is going to be x squared is equals to 20 minus x. Already is now a quadratic equation. Let us put it in a quadratic equation format, which is going to be x squared plus x minus 20 is equals to 0. From here, let us find the factors of 20 that will give us a solution to this. What are the factors of 20? Factors of 20 are such that we have minus 5 times 4. We can have minus 10 times 2. But without wasting our time, we need factors that will give us a positive 1. And as well as factors that are going to give us a positive 1 when we multiply. So this is going to be a positive 5 times negative 4. This is the pair that we're going to use here. So we open two brackets, equals to 0, and we put our factors. This is simply going to be x plus 5, x minus 4 equals to 0. So we have the values x is equal to negative 5 or x is equal to positive 4. So having these two values here, we must understand one thing, that because we had a square root, so our values of x that we find, they need to be tested in order to determine which one is a true value of the expression. In this case, what do? We need to test. How do we test? We test both values in the original. With the calculator, we're going to have x, when x is minus 5, we have negative 5 divided by square root of 20 minus negative 5. So when we punch a calculator, if it's minus 5, we're going to get negative 1. Let us test also for 4 divided by square root of 20 minus 4. This is going to give us positive 1. So if we can check, the left-hand side on the original question was equals to 1. In this case, we tested two values, which means when we substitute negative 5, we discover that it's giving us negative 1. So therefore, our final answer should look like this. We're going to say x is not equals to negative 5. We go ahead to adopt 4, which is x is equals to 4. These are the two values that will give us 5 good marks after finishing this. We go on to the next question. So moving on, we have a different kind of equation. This time around, we have a simultaneous equation. X plus y is equals to 9. And we have 2x squared minus y squared is equals to 7. This is equation 1. This is equation 2. We have equation 1 and we also have equation 2. So let us check how do we deal with this spontaneous equation. What we need to do is to target the equation which is linear. That is the equation which does not have x squared. And we create equation 3 from that. How do we do that? From equation 1, in equation 1, we have x being equals to 9 subtract y. This becomes equation 3. We have equation 3. We shall substitute this equation 3 into equation 2. Let us do that. Substituting this, it means 2. Where there's x, we put this 9 minus y. There's a squared here. Subtract y squared is equal to 7. So let's work our way from this, which means what we're going to have is that we expand by 4 method, 2 brackets, we have 81 minus 81 minus 18y plus y squared. Subtract y squared is equal to 7. Let us collect like terms and open bracket. This is going to be 162 minus 36y plus 2y squared minus y squared minus 7 is equal to 0. Let's make it to be a standard quadratic equation. So a standard quadratic equation, it entails that 2y squared minus y squared is going to give us y squared. Minus 36y is left, minus 36y here. And we also have 162 minus 7, which is going to give us positive 155 is equal to 0. Now it's time to solve this quadratic equation. Again, let us also deal with factors of 155. How do we get factors of 155? 155 can be found by 31 multiplied by 5. 31 multiplied by 5, it gives us 155. But if we introduce negative 31 times negative 5, this is going to give us negative 36 in this case. So we have our factors, which is y subtracting 31, y subtracting 5 is equal to 0. So these are the two values. Let us put them on the other side. We are going to have y is equal to positive 31, or y is equal to positive 5. These are the two values of y. Now, these are simultaneous equations. Once we find values of y, we also need to be in a position where we can also determine other values on the other side, which is x. We're going to substitute the values of y on x in order to find the two values of x. That means x is equal to be 9 minus 31 from this equation 3. 9 minus 31. What is the value of 9 minus 31? We're going to have the other value for x, which is negative 22. Or x is equal to 9 minus 5, which is equal to negative 4. So these are the two values of x. Once you are done at this stage, you have properly solved a simultaneous equation. Starting from creating equation 3, substitute equation 3 into equation 2. In this case, simplify everything until you create a proper quadratic equation here. On the other side, you need to solve this using quadratic formula. So in this case, at this stage, if you can't solve this by using this method of factorization by inspection, you can simply go ahead and solve this using a quadratic formula. So you can use quadratic formula, it will give you the very same answers, and which means our values are going to be y is equal to 31 or positive 5. We substitute in equation 3 in order to find the other y values. So let us move on to the next question. Question 1.3 on the question paper. Question 1.3, we have, we are given P being equal to 1 minus A. We are also given T being equal to 1 plus A. This is multiplied by 1 plus A squared. This is multiplied by 1 plus A4. These three dots, 1 plus A, 5, 1, 2. This is what we are given, and the pattern continues over and over and over again. So as we can see from this, what is the question? The question is determine P times T. The question is instructing you to determine the value of P multiplied by T. How do you determine P multiplied by T? Which means we need to see what pattern does it follow. Let's bring our P to multiply the T. So P is 1 minus A multiplied by the whole unit, 1 plus A. We have 1 plus A squared, 1 plus A4. The pattern continues. We can also add 1 plus A6. The pattern continues until the last one, 1 plus A512. But let us start by multiplying the first two values here. As we can see that this is a difference of two squares. Multiplying them, it gives us what? 1 minus A squared. If we multiply these two. But we still have an extension here. We continue 1 plus A squared 1 plus A4, 1 plus A6 continues to 1 plus A512. Again, let us multiply the first two we have here. What are they going to give us? It's a difference of two squares. It's going to be 1 minus A4. Using a 4 method, 1 times 1, A squared times A squared, it will give us a difference of two squares, which is 1 minus A4. And we continue, 1 plus A4, 1 plus A6, 3 dots, 1 plus A512. But if we can see the pattern here, is that as we continue to go down, they will still cancel out the difference of two squares. The difference of two squares on the first two, they will still cancel out, which means finally, as we continue the pattern, what we are going to have at the end of the day, we are going to have this last term here being multiplied by a difference of two squares of the same, which means finally our answer will be 1 minus A512, 1 plus the same one, the last one, A512, if we continue the same pattern. So at the end of the day, multiplying this one, this will give us 1 minus A exponent of, we add the two exponents that are going to give us 1024. This is the final answer that was going to give us 3 marks for this. So questions like these ones, they may be a bit challenging to approach, but what's important is for you to learn what kind of pattern are they following. So understanding that they were following a pattern whereby 1 minus A first, that was given, which is P, this one, multiply the first term here, that is this one. Those two, they gave us this, which is a difference of two squares. That difference of two squares is very similar to the next term on the sequence, which is this one, 1 plus A squared. Then they cancel out again to make another difference of two squares, which is 1 plus 4A4, which is going to be 1 minus A4. So as long as we see that the pattern continues over and over again, we finally get to understand. Let's move to the last term and let us change positive here, because the previous term, which is going to come here, is going to have a minus. So 1 minus A512, 1 plus A512, finally we have the answer, which is 1 minus A1024. So these were the questions that were examinable on the algebra of May, June 2024. So we need to move on now to series, sequence and series questions, which is question 2. So question number 2, on our sequences and series, we had the first question. We are given a geometric series, question 2, that was 4 plus 2 plus 1 plus half. The pattern continues, and it was an infinite series. So the first question on this one was that we were supposed to answer the question whether does this converge? Does this pattern converge? Does this pattern converge? For us to know if this pattern converges, we must understand what is the condition for convergence. The condition for convergence is such that minus 1 should be less than r should be less than 1. So let us determine the value of r here and see if it falls along these parameters. R in a geometric sequence is found by T2 over T1 or T3 over T2. So T2 is 2 divided by T1, which is 4. 2 over 4 is going to give us half. So our R in this case is 1 over 2. 1 over 2 satisfies this condition. It's not less than -1, it's not bigger than 1. So therefore, we can write that -1 is less than half and half is less than 1. So therefore, our answer is yes, it converges, because our R is within these two parameters. So let's move on to the next question. The next question is that you are asked to calculate what is called sum to infinity. sum to infinity. Sum to infinity in geometric sequence or series, it does have a formula. What is the formula for sum to infinity? It is a over 1 minus r. So since previously on the previous question we had already determined our value of a and our value of r, we can just substitute punch calculator and calculate the value. So in this case, our a, we are given our a, we still have which is in this case it is 4 divided by 1 minus r, which is half. So our pattern is still 4 plus 2 plus 1 plus half continuous. So our a is the term number 1. We put it here. Our r, we calculated on the previous question, is half. Finally, our answer is going to be 4 divided by negative half by positive half, which is going to be 8. So sum to infinity in this case is positive 8. That is sum to infinity of this question. So we move on to the next question. The next question demands, it's a completely different question. So as you are answering questions, be able to understand that the questions that you are attempting on the next questions, do they have anything to do with the previous question? We're approaching a totally different question, which is 2.2, whereby we are given sum to infinity. There's 10 here, there's p is equals to k, there's 3 to the power of p minus 1. They say already it's equals to 29, 5, 20. So the question is that we need to calculate the value of k. We need to calculate the value of k. Now, what matters now is how do we get the value of k? The way to get the value of k is by understanding what kind of a sequence is it. Let us test to determine the type of a sequence. So in this case, we are going to have term number 1 in this case is found. Term number 1 is found when p becomes k. If p in this case becomes k, we will find term number 1, which means 3 exponent k minus 1 is going to be our term number 1. Let us find term number 2. Term number 2 is when we find a term whereby we have k plus 1, because we are moving upwards until we reach 10. So k plus 1, k plus 2, k plus 3 until we reach 10. So in this case, our p is becoming k plus 1, which is going to be 3 exponent k plus 1. We subtract 1, which means our answer is going to be 3 exponent k. The pattern continues. To find T3, 3 exponent k plus 2. K plus 2, subtract 1 in this case. We are going to have 2 minus 1, which is going to be 3 exponent k plus 1. So the pattern continues over and over again. Although we can start from the back, from the end, p is becoming 10. When p becomes 10, we're going to put 3 dots. So we have the last term, the last one, when p becomes 10, 3 exponent 10 minus 1, we're going to have 3 exponent 9. So we can work our way backwards, just in order for us to be able to find the value of r, of a, and n. So in this case, we're going to have the formula for sum to infinite, sum to infinite of a geometric sequence. The formula is that sum of the first n terms is a bracket rn minus 1 divided by r minus 1. What is our a? Our a in this case is this one. This is our a, which is term number 1. How do we find r? Let us determine r. R is equals to T2 over T1. What is our T2? Is 3k over 3k minus 1. But if we simplify this using laws of exponents, we can see that this will become 3 to the power of k, subtract, because the bases are the same, we subtract exponents. It's going to be k minus 1 in this case, which is going to be 3 to the power of positive 1. So our r in this case is 3. Let us collect our data. Our R is 3. Our R is equals to 3. Our A is 3 exponent k minus 1. Our N is until 10. These are the values that we have. Let us substitute into the formula in order to find the value of k. Let us do that. So substituting this into the formula, we're going to have sum of the first n terms or 10 terms is given. 2, 9, 5, 20 is equals to A. A in this case is 3 exponent k minus 1. R is 3 exponent. Our N is 10 subtract 1 divided by R, which is 3 subtract 1. Sn is given. We substitute all the values here. We cross multiply, this becomes 2. So 2 bracket 2, 9, 5, 20 is equal to 3 exponent k minus 1 bracket 3 exponent 10 minus 1 remains here. So in order for us to simplify this side, divide both sides by 3 exponent 10 minus 1, this unit. That means if we multiply those two, multiplying them is going to give us 59040. 59040. If you punch calculator, divide by this, which is 3 exponent 10 subtract 1, is going to give us 3 exponent k minus 1. So far we're at this stage. We are at this stage with our sequence and our equation. In order to find the value of k, let's simplify the left hand side. Simplifying this one, this is going to give us a value which is going to be 3. on the left hand side, we're going to have 3 equals to 3 exponent k minus 1 when you punch calculator. So simplifying this left hand side will give us 1. If you punch your calculator properly, we give you 0.999, and 0.99 becomes 1. If it becomes 1, we turn this to become 3 exponent 0. 3 to the power of k minus 1. Base is the same, that means k minus 1 is equals to 0. So finally, k is equals to 1. This is the value of k. K is equals to 1. So let us understand what was happening here. We're saying this is a sum, it's a series, it's a geometric. Hence, we use this formula. After using this formula, already sum we know or we are given, which is this one. We substitute at this position here. Our A, since we tested our A, we have A in terms of k, number of terms, all the terms, they are 10. We substitute, we simplify here, cross multiply, 2, this 3 minus 1 becomes 2, cross multiply becomes this, equals to this one. So we divide both sides by this unit, like this. We are left with this until here, and we simplify until we get k is equals to 1. Let's move on to the next question. So on the next question, what we have is that we are given a quadratic sequence, which is 3, 7, 12. This is a quadratic sequence given. And what is the question? The question is about showing. We're supposed to show that this sequence can come down to nth term. It's half n squared plus 5 over 2n. This is what we should show, that when you solve this quadratic, it should come down to this. So, what is the nth term of a quadratic? A quadratic expression or a sequence, it has an nth term which is equal to a n squared plus b n plus c. So, we need to find the value of a, value of b, value of c, and show that they come down to this half n squared plus 5 over 2n. In order to do that, let us find the first differences to this. What are the first differences? 7 minus 3, we get 4. 12 minus 7, we get 5. Those are the first differences. Let us find a second difference. 5 minus 4, we get 1. Now, these are the second differences. These are the first differences. So, what we should do now, let us deal with the first difference first. This one. It is always equals to 2a. 2a is equals to 1. Divide both sides by 2. It means, therefore, a is equals to 1 over 2. Now that we found a, let us find b next. How do we find b? We manipulate the first difference, which is 4. In this case, we are saying 3a. The formula 3a plus b is equals to t2 minus t1. 3a plus b, let us substitute a is half, b we don't know, t2 minus t1 gives us 4. Let us simplify, b is equals to 4 subtract 3 times half. So when we simplify this, 4 minus 3 and half is going to give us what? Half, which is 1 over 2. We have a, which is 5 over 2 here. We have a, and we have b. So since we have a and b, what we need to do now is to be able to find value of c. How do we find the value of c? We substitute c into t1 is equals to a plus b plus c. Our t1 is 3. 3 is equals to a, which is half, our b, which is 5 over 2, our c. Therefore, if we simplify this, c becomes 0. We have a, we have b, and we have c. So simplifying this, it will come down to our nth term being equals to half n squared plus 5 over 2n. This is the final answer there, which is exactly the same as the nth term that we have been asked to do. So as we move on to the next question out of 6 marks, let us understand that as the question continues, we have a question. They said we need to find a number. What number must be added? What number must be added to tn minus 1? What number must be added to tn minus 1 in order to find that tn, so that tn will be equal to 13,527. So the question is, what is the approach of this question? The approach of this question is, first and foremost, let us determine the position of this 13,527. Because if we determine the position of that number, it means that we will know what is the position of tn minus 1. So far, tn minus 1, we don't know what position is it. We only know is that this tn minus 1, it is the previous term before the nth term. Let's repeat that. The tn minus 1 is the previous term before the nth term, which is the last term. So what we need to do, so far, first thing to do, let us determine position of this term first. How do we do that? We substitute tn, which is half n squared plus 5 over 2 n is equal to 13,527. Now let us make this a proper quadratic equation and solve. This is half n squared plus 5 over 2n minus 13,527 is equal to 0. Let us use quadratic formula. n is equal to negative b plus or minus b squared minus 4ac over 2a. So n is equal to negative b, negative 5 over 2 plus or minus our b is 5 over 2 squared, subtract 4, our a is half, our c is negative 13,527, everything over 2a, which is 2 brackets half. So for us to do this, we are looking for the value of n. So for the value of n, we are going to solve this, and we shall find, when we punch calculator, we shall find that n is equals to negative 167, or n is equals to 162. These are the position. So therefore n cannot be equal to this. So n is equals to 162 second term. So we have found the position. We have found the position. That is the position of that number. Let us check the position of Tn minus 1. What is that position? It is T. Our n is 162. So 162 minus 1, which is T 161. This is the position of Tn minus 1. So since this is the position of Tn minus 1, what are we going to do next? We are going to find that position by substituting into the quadratic equation, which is the nth term. So Tn, we know it's half n squared plus 5 over 2n. Let us substitute 161 into that and determine what is the term on that position. The term there is going to give us T 161 is half 161 squared plus 5 over n 161. Simplifying this with a calculator, it means we're going to find the value, which is 13,363. So Tn minus 1, it is 13,363. Now, to finally answer the question, let us get the difference between this number and this number. That is the number that must be added. Let us do that. We're going to have 13,527 subtract 13,363. If we simplify with the calculator, we shall find 164. So let us answer the question, what number must be added? The number must be 164 added to Tn minus 1, which is this one, to give us 30,527. This is how we simplify that. So let us move on to the next question. So the next question, which is about now an arithmetic. So the next question is that we are given in arithmetic, they say T1 is equal to 8, and also that Tn is equal to T2 is equal to 11. But already we are told that this is arithmetic. So if this is arithmetic, when we see this, the first thing to do is to make sure that let's make simultaneous equations. How do you make simultaneous equations? We should find nth term, a plus n minus 1 d. So far we don't know a, we don't know d. We only know position, which is number 1, and also term. So therefore a represents term number 1. Already we know it's 8. T1 already is 8. That means a is also 8. A is 8. Let us manipulate the second one. T2 is equal to a plus 2 minus 1 d T2, but we know a already is what? It's 8. Our T2 is 11. 11 is equal to 8 plus 2 minus 1 will just give us d. Therefore, it means d is going to be 11 minus 8, which is equal to 3. D is 3, a is 8. Now, we have A and we have D. Now, what was the question? The first question was to calculate a value of n. Calculate n if Tn is equal to 41. Let us calculate n if Tn is equal to 41. So since we know that Tn is equal to A, which is 8, plus n minus 1, D, which is 3 in this case, that means our Tn, which is 41, 8 plus n minus 1, we have 3. Let us solve for n. 41 subtract 8 divided by 3 is equal to n minus 1. So 41 subtract 8, 41, if we subtract 8, we are going to get 33. 33 divided by 3 is equal to n minus 1. 33 divided by 3 will give us 11. 11, 1 comes here, plus 1 is equal to n. So therefore, n is equal to 12. Which means, to find value of n, if Tn is equal to 41, it means n is equal to 12. This is the approach. When we have equations like this, it means that we shall follow the pattern of making simultaneous equations in this order in order to calculate the question that has been asked. The next question after this, we are still on the very same question, number 3. Our question number 3 was such that if we change and we make a new arithmetic sequence. How do we make the new arithmetic sequence? The new arithmetic sequence is such that we have P8 being equals to 1. We also have P11 being equals to 2. Then what is the first question? Write the value of P1. P41. We should write the value of P41. What is the value of P41? But this is a question that follows a previous question. What was the previous question? We found that Tn is equal to 41 and T12 is equal to 41 because we knew that we discovered or we calculated n became 12, so T12 is equal to 41. Then we have P8 be equals to 1, P11 be equals to 2. We exchange positions. That means P41 is simply equals to 12. It's a question for 1 mark. Determine P41. P41 is simply equals to 12. The last question on this sequence is question 3. You are being asked to determine the value of the first term. Value of the first term. How do you determine the value of the first term? So for us to determine the value of the first term, we must understand that Pn will be n minus 1 d. So far we know that P8 is equal to 1, so therefore when n becomes 8, Pn becomes 1. So 1 is equal to a plus n becomes 8, so 8 minus 1 multiplied by d. So 1 is equal to a, 8 minus 1, it gives you 7d. That becomes equation 1. The next one, we are given that P11 is equal to 2. P11 is equal to 2. So 2 is equal to a plus 11 minus 1 d. That means 2 is equal to a plus 10d. This becomes equation number 2. So we have 2 equations here, equation 1 and equation 2. Now, how do we determine the value of a? If we want the value of a, it means we must use either equation 1 or equation 2 to make subject or formula. In this case, let's make a subject. Making a subject, it means in equation 1, we have a being equals to 1 minus 7d. If it's 1 minus 7d, we substitute here. We are going to have 2 is equals to a. Our a is now 1 minus 7d plus 10d plus 10d. Let us simplify to find the value of d first before we can find the value of a. 2 is equals to 1 minus 7 plus 10 will give us plus 3d. Take 1 on the other side, it means 2 minus 1 becomes 1 is equals to 3d. Divide by 3, it means d is equals to 1 over 3. So we have d. Since we have d, we can substitute d into any of these equations in order to find the value of a. So let us substitute d into any of this. Let us use equation 1, equation 3. We are going to have d, which is going to be 1 is equal to a plus 7. d is 1 over 3. So let us simplify here. It means a is equal to 1 minus 7 over 3. 1 minus 7 over 3. Finally, our a will be equals to negative 4 over 3. This is the value of a. This is the value of a. So this was part 1 of our revision of May 2024, May-June 2024 paper. So watch out for part 2, which is going to come out with functions as well as finance questions. So thank you so much for watching. Those ones watching us for the first time, make sure that on your way out, you also don't forget to hit subscription button, to hit the like button, and also notification, so that next time we post more content, you'll be able to receive the content that we post. Thank you so much.